a couple of terminology, vocab words that we just are going to review. The radical symbol here is that guy. You should know what a radical symbol is. Square roots. We're talking about square roots today. Now the next word you probably don't know, or if you do, you might have forgotten. It's called the radicand. The radicand is the number under the square root. All right, because it's the English language and because that's just how things work, we like to put names for everything. So the number underneath the square root is called the radicand. What's one more word you know in your life? Now this next one you know before. We don't always talk about it in terms of a formal definition, but a number that you make, a number that's created by squaring another number, is called a perfect square. Okay, so you know what a perfect square is. It's something like 25 or 16. And you get 16 by squaring 4. That's why 16 is called a perfect square. Now, technically, when you take the square root of a number, how many answers are there? 4? What's that for? If I were to square root 4 here, technically, how many answers are there? There's 2. You would get positive 2 and negative 2, right? There's 2 answers. Today we're only going to look at. Today we're only going to talk about what's called the principal root, which is the positive square root. Now, starting tomorrow, when we do quadratic formula, when we do completing the square, we will look at the positive and negative answers of square roots. But today we're only dealing with the principal, the positive one. Okay? And finally, we talked a little bit about this yesterday, an irrational number is a number that cannot be written as a fraction or as a terminating decimal. So that's a number like the square root of 2. I can't break down the square root of 2. I can't write it as a fraction. It's just a decimal that goes on forever. Okay, so we're going to be looking at some irrational numbers today, too. Okay? All good vocab words. Let's talk about perfect squares, because we're going to be simplifying square roots today. That's what the lesson is about. So you guys did your know your powers not too long ago, so this first part should be super easy for you. We're going to write out the first 12 perfect squares, just so we can use them to reference as we go. Right? So the first one is 1, 2 squared is 4. We're going to do this whole list here. So 4, 9, 16. Okay, so just take a second and write out all your perfect squares. And you should know these, and you can do them in your head later on, but for today, sometimes it's nice just to visually be able to look at them. Because we're going to be using 2 different methods, or I'm going to show you 2 different methods for simplifying square roots. I don't care which method you use. My personal preference is the method of perfect squares, the first one we're going to do. I'm going to remind you how to make a factor tree. Depends who your geometry teacher was last year. So I know, like, if you had Mrs. Collini, I'm pretty sure she does perfect squares. If you had Mr. Hunt or Mr. Carr or Mr. Lamb, I think, do the factor tree. So it just kind of depends. I'll show you both, and then you can pick whatever you like. So the reason I like perfect squares is because it's actually really quick. This will be the longest one we do, but I like perfect squares better. So what we have to do is think about the square root of 72. I want you to look at this really long list of numbers that we just wrote. What is the biggest number in this list, the biggest perfect square that multiplies into 72? Okay, Jen? 36. 36 times what? 2. So I'm going to rewrite that as a square root of 36 times 2. Now, the really nice thing about radicals is that radicals can break up over top of multiplication. So you could rewrite this as radical 36 times radical 2. Why? Because what's the square root of 36? 6. So this is 6. Does radical 2 break down? No. So there's your answer, 6 radical 2. Now that's probably the most writing I'll ever do for one of those problems. Okay? But I like this because it's pretty quick. You think about a perfect square, you take the square root of it, you're done. Factor tree, some people really like. It's fine, it just takes a little longer sometimes. So let's use the method of factor tree to break down radical 80. So what we're going to do is we're going to break down 80 into all of its prime factors. So I just want you to tell me 2 numbers that multiply to 80. Any 2 numbers?
4
40 and 2 works. So we'll do 40 and 2. All right, now we need to break down the 80. 40, sorry. 2 is a prime number, so 40. What goes into 40? 20 and 2. All right, we're going to go the long way here. What goes into 20?
5 and 4.
Let's do 5. Let's do 5 and 4. And 4 breaks down to be?
2 and 2.
2 and 2. Now, if you had a teacher who did the method of factories, they potentially, at least one of the teachers I know who do this, sometimes tell a story about being at a nightclub. Or not really a story, but like a little thing about, we're going to pretend. We're going to pretend that radical is the bouncer at a nightclub. And you can't, it's called buddy system, right? You can't leave the nightclub without a buddy. It's just not safe. What? I actually don't have, what?
You wouldn't know how.
That's right, you probably shouldn't know that. I don't think I've never been to a nightclub. So I don't know that, but like the way your life works, you should not go somewhere without a buddy. So the bouncer doesn't let you leave. So what we're gonna do is we're gonna buddy up the numbers. Shaking my head. Okay, so remember the bouncer is the square root. The radical is simple. And we need to find some buddies. So does 2 have a buddy? Are there other 2s here? Yeah, there are. These guys have a buddy.
Come on.
The 2s buddy up. You can only buddy up with the same number. You can only buddy up with people that look like you. It's not a very good system, but it's a system. So these 2 buddy up. Do these 2 have buddies?
Yeah.
Yeah, they can buddy up. They can leave the nightclub together. So when these 2 leave the nightclub, right? I forgot this part. When these 2 leave the nightclub, this set of buddies, I'm going to put a 2 out in front, right? I get 1 outside for the 2 of them. I forget that part of the story, why that works, but it does. So from one buddy, put a 2 out front. From this buddy, how many 2s do I write out in front? Another one. So I have another pair of 2 that leave. Now, does 5 get a buddy? No. Poor 5. He doesn't get to leave the nightclub. Maybe that's a good thing, maybe that's a bad thing. He doesn't get to leave the nightclub, so he is stuck inside. The bouncer won't let him leave. Well, can you simplify 2 times 2? Yeah, this is 4. Radical 5. And that's the final answer.
Why couldn't you use 4?
4's not, you use the numbers at the bottom. The primes. So you're only looking at, hold on, the highlighter is gone. You're only looking at these. Because you get a 2 from out here, a 2 from this set of buddies, right? Because this is really like 4. 2 times 2 is 4, but it's under a radical. Radical 4 is 2. Type it in your calculator. 4 radical 5. It's the same as radical 8.
Well, let's see.
That's why I don't like this method, because there's so many questions. Like, it's just, that's so much easier. Yeah.
Why is only 5 and 5?
Because he doesn't have a buddy, so he can't leave.
Well, she's not good.
But those aren't the primes. Remember, we broke this down into primes. You're only looking at the numbers in yellow. You look at the prime numbers at the bottom. Yeah, the rest of the numbers, we can pretend they're gone. Because if you think about it, if you took your calculator, 5 times 2 times 2 times 2 times 2 gives you 80. But here's why this method to me is just kind of like a lot of extra work. Because think about 80, right? Take your calculator for me. I'm just verifying to you. Take 80 divided by 16. What do you get? 5. All right, so radical 80 is the same thing as square root of 16 times square root of 5. And what's the square root of 16? 4. Is that the same answer? Did I get that in like a fraction of the time? Yes. That's why I like perfect squares better. However, if you really like the factor tree, if that's all you know, or if you just like that, be my guest. You can do factor tree all day long. I just don't know. And maybe I'm not good at explaining it. I don't know. I just don't care for it. So, I have a bias. Alright, so let's practice some square roots. And then we'll teach you a new number. We won't do all the problems on the front, but let's see where we start. So I look at 63. I think about 63 and think, what's the biggest perfect square that goes into radical 63? 9. So I rewrite this as radical 9. And what do I multiply 9 by to 63? 7. So I have radical 9 times radical 7. Well, what's the square root of 9? 3. So this is just 3 radical 7. That's it. You're done. And if you wanted to check your answer, you could take the square root of 63 in your calculator, hit enter, and see, oh, is that equal to 3 radical 7. And it is. So you can check your work. You know you got the right thing. Okay? So when I look at the next one here, I have radical 50. What's the biggest perfect square that goes into 50? 25. So you write radical 25 times radical 2. And what does that simplify to be? 5 radical 2. Yeah.
I forgot.
Alright, what about radical 81? Yeah, just 9. Do you need to do perfect squares here? No, I mean you could. You could rewrite radical 81 as radical 9 times radical 9, which is 3 times 3, which equals 9, but that's a lot of extra work if you can just remember that radical 81 equals 9. Okay? You good so far? Alright, let's see. Pick one in this row. 6, yeah, 6 is a good one. So the nice thing about radicals, just like multiplication, is that square roots break up over fractions. So you can rewrite this as radical 5 over radical 24. Right? The radical will break up over top of a fraction for you. Well, does radical 5 break down the numerator? No. So the numerator is going to stay radical 5. Does radical 4 have a perfect square that goes into it? It does. 4. 4 times what? No. 4 times 6. Numbers are not working for you today. Okay, so what's square root of 4? 2. So this is really radical 5 over 2 radical 6. And you can leave that as your answer. Now, I think in geometry you did rationalizing fractions. Yeah, technically you should do that here, but we're not going to do it today. We'll do rationalizing. That means you're not allowed to leave the radical in the denominator. You have to like multiply and yeah. We'll do that later this year, but we don't need to worry about it today. Okay? Now, sometimes we're going to have problems where you're going to have a coefficient on the value. So we're going to pick 2 of them in this row. Right? There's a number outside of the radical that's going to affect our answer. So let's just start with number 1. If I have 6 times radical 12, that 6 is just going to hang out. It's not going anywhere. 6 is just there. What perfect square goes into 12? 4. So I have 6, times radical 4. And 4 times what is 12? 3. So I have 6, radical 4, radical 3. Well, what's radical 4? 2. So I have 6 times 2 radical 3, which simplifies to be 12 radical 3. Good. Right? So if you have a coefficient there, you just let it hang out so you're ready and multiply it by 2 or 3. Which one do you want to do? 3? Okay, let me do 3. Let's do 3. So I have radical 18 over 2. Is there a perfect square that goes into 18? Yeah, it's 9. So I'm going to rewrite the numerator as radical 9 times radical 2 all over 2. How does that fraction simplify? 3 radical 2 over 2. Now you just have to decide, does 3 over 2 simplify? No. Am I allowed to simplify radical 2 divided by the 2? No, because this 2 is not under a radical, so I'm not allowed to cancel off those 4 roots. So that's actually your final answer, 3 radical 2 over 2. Okay, good so far? Have you done that? Remember doing that at some point? Okay, flip your paper over. You're going to learn a new number. This is a great number. It's great.
Loved it.
You've learned E this year. Last unit, or 2 units ago, you learned the number E. Today, we're going to learn about the number I. Now, when I was in college, I think I told you, I took a philosophy and history of math class, and we had our final exam was a research paper, and I wrote a 30-page paper on I and complex numbers. So it's really cool. There's actually really good history to it. There's guns involved. There's mathematicians dueling each other. All kinds of drama. Yeah, they actually shot at each other. Tartaglia and Cardano were their names. Cool. Yeah, mathematicians used to be highly revered people. They were important. People, they would write each other, and there would be all these scandalous things, and they would meet up and public places and like math, like do math problems, like throw hard problems at each other to see if they could trick them. And then these people, Cardano and Tartaglia, actually like physically with guns fought each other over this. So, it's a true story. Look it up. I'll bring my paper. You can read it. So up until today, if you saw the square root of negative 16, we're just like, well, can't simplify it. Too bad. Not a real thing. Well, unfortunately, or fortunately for you, depending on how you look at it, you now can simplify that square root. And it comes by knowing that the square root of negative 1 is equal to the number I. I is called an imaginary number. Alright, so it's not real, it's imaginary. But it's a real thing? Is that like, that doesn't make any sense. It's a real number, but it's imaginary? So, just go with it. So the hard thing about imaginary numbers is you can't see them. Like, we can't plot them, like we can't be like, oh, look at that number line on the wall, that's for I. Because it's not, that's the real number line, so it's not on the number line. But it exists, it has purposes in math. Like, for now, simplifying square roots, the actual application of it is theoretical. Like, you're not going to use it in, yeah. I'll try to show you like tomorrow you'll see like a picture where it would show up in math, but like, yeah, there's no actual, I can't give you a concrete, like this, like if you, some like STEM fields will use it in their work, but it's not like, oh, this, to build a building you have to know I. Like, you don't, it's a theoretical concept, but. It exists in the imaginary number system. Yes. So there's like the real number system, there's complex, there's rational numbers, irrational numbers. This is an imaginary number system. So it's like a set of the numbers called imaginary numbers. I know, it's very weird. Yes, Andrew. Infinitely many imaginary numbers. How many regular numbers are there?
There's 11.
Infinitely many. So you could take an imaginary version of every one of those numbers.
So, like 11.
Yes, like 11. 11I. Alright, well, let's talk about how I works. So I, remember, I is just the square root of negative 1. So when you are simplifying square roots here, when you factor, when you pull out those perfect square factors, if there's a negative under the radical, you're going to pull out square root of negative 1. So for example, in A, I have negative 16. So that's really negative 1 times 16, right? So I'm going to rewrite this as the square root of negative 1 times the square root of 16. Okay, the negative 1 comes out under the square root as one of the square root factors. Well, what is the square root of 16? 4. What's the square root of negative 1, did we just say? It's I. Well, I'm not that close to it today. It's I. So you have I times 4. However, the convention is we don't really do I4. We typically write that as 4I. Right? That's how, you can do I in front of the 4, but the way you're going to see it written is the I at the end. So that's equal to 4I. That's the answer. If I had the square root of negative 40, first thing I do is notice there's a negative under the radical. So I start by writing the square root of negative 1. Now I break down the rest of this the same way we did on the front of our notes. What's the biggest perfect square that goes into 40? No, that's not perfect square. 20 doesn't go into 40. 20 is not a perfect square.
I'm really not
4. Yeah, you're off your game today. Radical 4 times radical 10. Well, radical 10 doesn't break down, so you still have radical 10 in your answer. Square root of 4 is 2, and the square root of negative 1 is I. We usually stick the I after the number. Or you could do I2 radical 10, but we write it 2I radical 10. And that's the value. Okay. What about negative 18? I start by pulling out the negative 1, square root of negative 1. What's the perfect square that goes into 18? 9. So I have radical 9 times radical 2. How do you think this is going to simplify? 3I radical 2. Yeah, that's it. Right? You seeing this okay so far? Or listen, let's look at a couple in the next row, and then we'll give you some time to work on your practice. So let's pick 2 of them in this row. Which ones do you want to do? F, okay, and H? F and H works. Alright, so when I look at square root of negative 11, first thing I have a negative, so I pull out square root of negative, oops, that's not right. Square root of negative 1. Now, I have square root of 11 left. Is there a perfect square that goes into 11? No. So I just have square root of negative 1 times square root of 11. And since radical 11 does not break down, what is the square root of negative 1? I. So I just stick 9 for I radical 11. That's the answer. What? That's what goes. Alright, what about H? I have a coefficient this time. So I start with a 6. The 6 just hangs out. I have a negative. So the negative means that I have to pull out the square root of negative 1. That's one of the factors. And what's the biggest perfect square that goes into 90? 9. 9 times what? 10. So I'll have square root of 9 times the square root of 10. I broke that down into as many perfect squares and factors as I need. Well, the 6 hangs out. I haven't done anything with him yet. Square root of negative 1 is I. What's the square root of 9? 3. So I have 6i times 3 times radical 10. What can I do with the 6i and 3? I can multiply to make it what? 18i radical 10. And that would be the simplest form. The only drawback to working with I is, you can't type it into your calculator. A calculator doesn't do I. It only does real numbers. So like the front of our notes you can type in to check and verify your answer. These ones you can't. The only thing I would say is if you typed in, if you did it without the negative here, you could at least check that the number part is right. Some of the calculators have I.
If we change it from real to a plus ei, you can do it with calculator.
Interesting. I actually didn't know that. Oh, I could change. Yeah, here, real, I could do complex. Interesting. I didn't. Does it put I in the calculator? Oh, so if I typed in, let's see. Oh, let's try this, guys. This is fun. Okay, so I'm changing the mode here. I didn't know this. So if I typed in the square root of negative 9, oh, it gives me 3i. That's so cool. Okay, so if I did the square root of negative 90, it won't break down the square root, but it at least puts an I on there so you can check your answer. Because what did we say? We had 18i, although I don't have an I. But if I did 18 radical 10, oh, that's so cool. All right, now you know I did it. This is fun.